giving you problems to do in acid solutions, basic solutions, and then just regular, where you have to do the half reactions, and then just regular oxidation, reduction, balancing equations. So if we have this, and here we've got, okay, so the first thing we do is figure out the charges of everything that's being changed. This is pretty obvious, it's +2. What's my magnesium here?
+7.
Manganese. +7, and everything else we've already got. So we're going from, on iron, we're going from Fe +2 to Fe +3, and here we're going from manganese oxide to just manganese +2. Those are your two half reactions. Okay. Then we're going to balance our ions. This is the third step. We've got one iron here, anything that's not oxygen or hydrogen. One iron here, one iron here. One manganese here, one manganese here. So we don't have to adjust anything in this case. But now we're going to go in and adjust the charges, right? So if I'm going from a +2 here to a +3 here, I've got to add, to make them the same, I'm going to add +1 electron here. Now what am I going to do on the other side?
Add 5 electrons with your manganese with oxygen.
On that side. Is everybody okay with that?
Where do you get 5 electrons?
All right. We've got, here we're at what charge?
+7.
+7, and we're going to go to a +2. So +7 minus 5 is +2. Yeah, we don't deal with the oxygens. Remember, we decided that this was a +7 up here. So now I'm having to get the same number, the charges balanced on either side, as far as the number of electrons, not the charges, but the number of electrons on either side. Okay, so I'm okay with that step. Okay. Then the next step is we're going to add water to balance hydrogens and oxygens. Why is this step not doing that? Okay. So we don't have to do any balancing here, but here we're going to have to. We're going to add how many waters?
4.
I'm going to have to add 4.
And then 8 hydrogen.
Okay. So now I've got 4 oxygens here and 4 oxygens here. What am I going to have? But I've got to balance my hydrogens too. So what do I need to add over here?
8.
And we're just adding hydrogen ions. You're what?
Why do we add 4 waters instead of just 4 oxygen?
Because I'm adding oxygen by adding water. And I had 4 oxygens here, so I had to add 4 waters here to get 4 oxygens on this side. And then since with the water came hydrogen, I had to add the hydrogen over here.
To balance it out.
To balance the numbers out of each.
Okay.
So on the paper, do we not need step 4?
Step,
did you just combine them?
I just combined them.
Okay.
Because it's not really telling you in step 4, why are you adding those hydrogens if you haven't added the water yet? Okay. So then, the last step is to balance out the same number of electrons here and the same number of electrons there in both equations. So I've got 5 electrons here, so I'm gonna have to multiply this whole thing by 5. And then that becomes 5 Fe plus 2 yields 5 Fe plus 3 plus 5 electrons. Then we just add everything. So 8 hydrogens plus 5 electrons plus NO4 plus 5 Fe yields Mn plus 2 plus 4 H2O plus 5 Fe plus 3 plus 5 electrons. So I've just combined everything in these 2 equations. My electrons cancel out. And the final answer is this, 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 and this. So the final is 8H plus MnO4 plus 5 Fe plus 2 yields Mn plus 2 plus 4 H2O plus 5 Fe plus 3. And that's it. Piece of cake, right?
Mm-hmm.
Why are you multiplying the iron times 5?
Because we had to get the same number of electrons. I had 5 electrons here on the reactant side,
Okay.
so I had to get 5 electrons there. You gotta get the same number of electrons on both sides of the equal sign, so you can cancel them out.
That can clear it up.
Okay, shall we try another one?
Yeah.
Alright.
Is this the last thing we're gonna learn from this chapter? For these reactions, or is it?
Well, I'm supposed to go over the battery stuff, but if you'll read that, I'll spare you lecture on it.
Okay.
This test that you're taking, did you say it's gonna be a lot of review?
The test? I'm gonna do a review sheet for you.
For the final? Okay.
But the test that I'm gonna post tomorrow is,
I just can't imagine it's gonna be very long. There's only like 2 weeks a lecture, because we were out for the first week of July.
what's gonna be very long? The final?
No, the test we're about to take, seems like it's gonna be really small.
It is. But it's gonna be on chapters, what is it, 15 and 16. So you got the nuclear chemistry stuff in there.
But that's the only stuff is that
And this.
nuclear chemistry stuff in there.
Because this stuff's so confusing.
Oxidation reduction is basically what it's about. That's it.
And then the lab. What's gonna be on the lab part?
The lab part, what lab did we do last week?
The movie?
Manhattan Project.
The Manhattan Project, that's right. Manhattan Project, so there could be questions from that. There could be questions from today.
Will you hand those back if we turn them in, or can you give them back before you grade them?
I can.
Okay.
She says that, but she never gets them back in.
I forgot and turned mine in.
You turned yours in already?
Yes.
Yeah, we'll get you back. It's on my desk.
Okay.
I'll bring it tomorrow. And tomorrow, if you want, we'll go over, I'm gonna go over the next example on the worksheet. And, then let you guys kinda work it and go over the rest of it tomorrow. Or do you feel like you have a better understanding of the oxidation reduction stuff at all?
I do.
Hmm?
I kinda know what's going on now. I was completely lost yesterday.
The only thing is, I don't know if I just completely overlooked it, but remember when you went over the one with the base in it?
Right.
So does it tell you at the beginning that it's a base, or do you just tell by looking at it?
You should know by looking at it whether it's a base or an acid.
What
Acids
is-
are proton donors, bases are proton acceptors.
Yeah, but there wasn't an OH, we just added an OH at the end.
But if it's a,
There's an MnO4 and iron.
I don't have to tell you, if you'll notice, it says on the worksheet, balance the following equations in acidic solution.
Okay.
So you'll have to know in that. But NO3, -1, wouldn't be a base. It could be made into an acid, but not a base. Because it can take a hydrogen. And while there's nothing in there that is donating a hydrogen, it could take a hydrogen. So that would make it an acid. Alright. So let me actually work that one. So we've got Cu plus NO3 minus yields NO plus Cu. Plus 2. So
Is that nitrogen and oxygen
what?
on the product side?
Yeah. Better?
Mm-hmm.
Okay. So it says it's in acidic solution, but like I said, if I didn't tell you that, that's going to accept a hydrogen and become an acid. But I will at least tell you what it is. So if we look at this, what are our different charges?
0 for the C.
Cu is 0.
The N is gonna be +5.
Copper's by itself, it's 0, bless you.
The N is +5,
Okay.
and the O is -6.
And
The
then plus 2
nitrogen,
and
I'm
-2.
confused, is that gonna be a +2
+2 and a -2.
and a -2?
Mm-hmm.
And that
So
should
that
be-
the whole thing is 0.
And that's 0 over there.
And this is +2, it tells you.
Okay.
Even though when they're written by themselves, they're normally 0, but in this case, it's telling you what it is. So, and this is where these differentiate from the others, because they are defining charges, and they're defining charges because it's in an acidic solution. Versus if you're not in any kind of solution, then you would balance it by its charge. So we've got copper going to Cu plus 2, and we've got NO3 negative going to NO. Now, then we balance the ions. So what do we need to do?
And 2 electrons to this.
2 electrons, 2
Okay,
plus 2.
when we say, first of all, when we say we balance the ions, we balance everything but hydrogen and oxygen. 1 copper, we're okay. 1 nitrogen, we're okay. We don't worry about the oxygens. Okay. There's 3 over here and 1 over here. normally you'd wanna put a 3 there to get those oxygens balanced, but in oxidation reduction ones, we don't. Okay? So now we're gonna do the water. So I'm gonna have to add none here, but I'm gonna add how much here?
2 there.
Add 2 there. So if that's the case, then I'm gonna have to add how many hydrogens over
4.
here? Plus 4 hydrogens. Okay. Then I balance the charges, or the number of electrons. So what am I gonna have to do with this one,
On that one, 4,
You're going crazy over here.
5.
So when you,
So
the
why,
copper, and the copper too,
yeah, why wouldn't we add the electrons? You press
To the,
So don't you need to add 3 electrons to the hydrogen side?
cause I was just still working with this one since we're on that one and adding the hydrogens and water. We didn't have to add water up here because we didn't have any oxygens or hydrogens to balance. So now that we've got the water balanced, or the hydrogen and oxygen balanced, let's go ahead and do the electrons on this one. And what'd you say?
3, oh, I said 3 electrons on the hydrogen side.
3 electrons here, good. Why?
Cause it's, positive 3 and 0.
Over here?
It's 0 over there and it's positive 3 on the other side.
Good. Okay, so now let's do the copper. What are we gonna have to do there?
don't you gotta multiply by 5?
Now we gotta get the charges, the electrons balanced. This is 0, so I'm gonna have to add.
No.
That's probably the worst part, is counting out the charges.
No, multiply the top one by 3 and the bottom one by 2.
Alright, now we've gotta balance the number of electrons. I've got 3 here and 2 here, so I'm gonna have to multiply this whole thing by 3. And then this whole thing by 2. So I have 6 electrons on the reactant side and 6 electrons on the product side.
I forgot, how do we determine what we multiply by again?
Common denominator, pretty much.
Okay. So we got, I see the 2 electrons at the end of the, copper.
Okay.
So we gotta take those same 2 electrons, and we gotta multiply 2 by the 3 electrons and the 4 hydrogen and all that.
To get the same number of electrons on both the product and reactant. Do you see where the 3 came from?
The 3 came from the 0,
We had plus 4 here
Plus
and minus 1, so I had a plus 3 over here
okay.
and a 0 over here. So I had to take away, I had to add electrons over here to make it 0 as well.
I just figured that you got, because we had a plus 3 with the, 3 oxygens on, the reactant side.
Huh. It's from the charge, not from the oxygens. Adding the water was to get the oxygens balanced.
Okay. So that's what the H2O is.
Right, is to get the oxygens balanced.
Okay.
But then after you get that balanced, the next step is to balance the overall charge from side to side. And since this has 4 positives and 1 negative, how do I get that to be 0? I've got to add 3 more negatives.
Okay.
Because this is 0. This essentially had no charge, right, when we went up there?
Mhm.
And water is balanced, is 0. Plus 2 minus 2.
Okay, I see how you do it.
But these sides were ions and had charges to it, so we had to add the electrons to get those charges gone.
Okay, so because we had 2 electrons in the first, with the copper, 2 electrons, then we know to multiply the other equation by 2?
Well, yeah, we had two electrons over there and 3 electrons over here. What's their common denominator? 6. So I have to get a total of 6 on both sides, because you want the electrons to cancel out. Okay, now we've got those balanced, so we just add everything together. So 2 times 3 is 6 electrons. 2 times that is plus 8 hydrogen ions plus 2 NO3 plus 3 Cu yields 2 NO.
4 high waters. 3 copper plus 2.
6 electrons. And the electrons cancel.
And the electrons are on opposite sides, so they cancel. So the final balanced equation is 8 hydrogens plus 2 NO3 plus 3 Cu yields 2 NO plus 4 H2O plus 3 Cu plus 2.
And your NO3
So would I be wrong if I put the negative charge over the 2 and over 3?
Oh, no, I should have that there. Just left it off. Me and my negatives. Me and my signs. Better than yesterday?
And this is our test that's coming up tomorrow, it's gonna have this on there.
Alright. You wanna do one with a basic solution?
Mm-hmm.
Okay. The processes or the steps are basically the same. No pun intended. Alright, so we've got, let's do Ca plus H2O yields CaOH2 plus H2. Alright, so first step, charges,
0
0.
plus 2 minus 2.
So it's basically plus 2 minus 2, which is basically 0. 2 minus 2. And the hydrogen have a charge to it?
How do you get, -2 right there? I see the oxygen.
OH, remember that's a polyatomic ion? Has a -1 charge, so
Okay. Oh, okay, I see.
okay. So next step is to take our Ca. Is going from Ca to CaOH2.
H2O.
I'm not sure. I guess the H should have, it didn't put it on the worksheet, but shouldn't that have a plus?
Even though it's a diatomic.
I guess because it is diatomic, we don't need to do that. Yeah, we still 0. Okay? So, balance the atoms, other than hydrogen and oxygen. So we're good, right? So now that add the number of electrons. Do we have to add any electrons to anything?
No.
We do not. So then what? We have water to balance, well, we had the water to balance.
Oxygen.
So I've got to add H2O here.
And then to the other side of that, won't you have to add 2 more hydrogen to balance that?
Why didn't we just put a 2 in front of the H2O that was already there?
That's separate.
Because it goes on this side.
Separate.
They're two, you're talking about here?
Yeah.
Cause they're two separate reactions at this point.
Okay.
And then,
So I have to do this.
Add H2.
So we add H2O to acidic and basic.
and add plus 2 hydrogens to the water side.
Or with these, we can do actually that, and then with this, we can do 2OH. With the bases, we add OHs. We add water to get the oxygens and hydrogens balanced. We can also just add OHs.
So you can add
We still need to
H2O or
add-
OH.
You still need to add 2 hydrogens to the other side. Now you need to balance your electrons.
Okay?
So you need to add 2 electrons to the hydrogen side on the top one. Bring it back to 0.
Okay?
And then on the bottom one, you need to add 2 electrons to the product side. Oh yeah, that side.
So the bottom has 2 oxygens on one side and just 1 on the other, and that's okay?
It's gonna have,
It should just
Okay,
be
hold
1
on.
OH and just 1 hydrogen.
one OH.
And 1 hydrogen and then only 1
And that's
electron.
1 electron. Alright, let's count this. 3, 1, 3, 1. Okay. But OH is a negative.
Oh, so then
So
you're
that
balanced.
balances out completely, doesn't it? Positive 1, negative 1.
And then you have to multiply the bottom by 2. What do you if you don't have any added electrons?
So the electrons in this would stay?
Then we must not need to add those 2 electrons on top. This is what we're gonna do. That's what we're gonna do. So then, our electrons balance out, right?
Well, no, cause the other side's 0.
Yeah.
Okay, so we've gotta add 2 electrons plus here. And we've got that balanced. We're still gonna end up with 2 electrons.
If you put the bottom one, the OH on the bottom at 2, wouldn't you just put a 2 in front of the hydrogen, the water? And that would just balance out the bottom?
We don't need to.
We
Then
can't-
there would be like
we
2
don't need to.
electrons added.
Cause we've gotta balance it using the OHs. It says balance the charge in each half reaction by H plus in acidic solutions or adding OH in basic solutions. So we had an OH here. And we had an OH there, but we had to add another. If we do this, instead of adding that, if we do this. And then that. Okay, that's what you were saying. I think that'll work. It's the whole water thing that's throwing everybody else. Okay, so we got 2 OHs on and 2 OHs, and now over here, do we have to add any ions?
You still need to add 2 electrons.
We've gotta add 2 or 1?
electrons.
2. Let's do it.
Okay. And now, our electrons balance out. So we can add everything together. It's 2 OH plus Ca plus 2 E negative plus 2 H2O yields CaOH2 plus 2 E negative plus H2 plus 2 OH. You're right, I was trying to add hydrogen where I didn't need to.
And then cancel out your
And
electrons.
you cancel out your electrons. So then the whole thing is 2OH plus Ca plus 2H2O equals CaOH2 plus H2 plus 2OH negative. So acids you add water or hydrogens, in bases you add OHs. Okay, not so bad. Does anybody remember how we go back and do the standard ones? Oxidation of the last one.
Word.
Huh? The last page. All right. So if we've got H2S plus HNO3 yields sulfur plus that plus water. All right, so now we're going to assign oxidation numbers.
Degree -2 plus positive.
Okay.
That oxygen will make that, oxygen
Isn't
-6.
NO3 -1?
That will, and, hydrogen will be +1, and nitrogen will be +5.
Good?
And that sulfur will be 0.
Yep.
That nitrogen will be a +2.
+2, +2. And +2.
+2 minus 2.
How come the NO3 isn't a -1 on this one? Oh, I guess it is when you put them together, isn't it?
Why isn't the NO3 negative?
Oh, okay.
Yeah, when you put them together, they are.
Yeah, when you put them together.
+5 and the -6. Okay. So now we gotta balance electron loss and gain by adding coefficients to the reactor. Oh, wait a minute. Assign oxidation numbers to all elements and define, making sure my rules are right too. Oxide, if only one element is both oxidized, okay. So we've gotta go through hydrogen, does it change? No. Sulfur goes from -2 to 0. And what about our nitrogen?
Nitrogen
Nitrogen goes from +5 to +2.
Okay. So now what? You know what to do?
Yeah, you gotta tell which one is oxidized, which one is produced.
Okay, which one is oxidized?
One is oxidized, which means.
Oxidized means you gain
You
electrons?
gain.
No, you lose
Sulfur,
electrons and
yes.
get more positive.
You lose electrons is
So
also
sulfur.
oxidation.
So that's
So
nitrogen.
sulfur oxidized because it got more positive.
Yep.
And the nitrogen reduced because it
Wait a
got
minute, wait. Lose electrons oxidized, Leo, and GER, so it's reduced. Good. Just have to think for a minute. So which one's the oxidizing agent?
the nitrogen.
And reducing agent?
Sulfur.
Sulfur. Okay. Now it says balance the elements oxidized and reduced by adding coefficients to the products. So we've lost what? We've got 2 E's here and 3 E's on this side.
So you need to multiply all the sulfurs by 3 and all the nitrogens by 2.
All the sulfurs by 3 and all the nitrogens by 2 to get the common denominator of 6. So all the sulfurs by 3 and nitrogens by 2. So are we done? 6 hydrogens? Actually 6, 7, 8 hydrogens. 3 sulfurs, 3 sulfurs, 2 nitrogens, 2 nitrogens, 6 oxygen, and we've got 2, 3. So we know we've got to balance the water now by doing that. And we're done.
This makes a lot more sense to me now that we did the way more complicated ones. Now I see what the extra electrons are for.
Okay, so to try this sheet tonight, we'll go over the rest of it tomorrow, or whatever problems you might have with it tomorrow. And I'll talk a little bit about batteries tomorrow. Just a little bit.